you learn how to work out the areas of a whole bunch of shapes, right? At least 4 or 5. Can anyone help me? Remember, what are some of the shapes that we've learned the area for? Yeah, Tendai. The trapezium. Whoa, let's go straight for the hard one. Okay. So the trapezium, right? What's the area of a trapezium? Who remembers it? Ooh, it's a tricky one. This is a hard one. Jordan, you want to give it a go?
Half A plus B.
Okay, yep. Okay, very good. The trapezium is actually one of the hardest ones. Okay, so well done. We went straight for a tricky one. How about a simpler shape? Simple shape. Yeah.
Square.
The square. Thank you. Okay, I'm just going to start drawing them because you guys know what these are. Okay, what's the area of a square? What's the formula? What's the formula, Ethan?
Perimeter square.
Oh, almost. Yeah. Around the edge, it's the side, isn't it? Yep. The side squared. Very good. Another one. Another. The triangle. Okay. What's our area of a triangle? Will?
Width times space times half.
Oh, yeah, okay, half. We usually say base instead of width, but width is fine. Okay, I like that, good. We've got 3 shapes so far. Let's have another one. Shane, did you have a hand up, or were you going to answer this question? Never mind, that's okay. All right, Brandon.
Rectangle.
Rectangle, thank you. All right, so to make this a little longer here, what's our area of rectangle if it's like, you know, this broad, its breadth, and it's like this long, its length? What's our formula, Nathan?
Isn't it just the same as a square?
It is just like a square, except the square is a special rectangle, so the 2 sides are the same. So here, because the sides are different, we just multiply them, yeah? Usually we call it length times breadth. Does it matter which one's which?
Yeah.
Not really, because like 5 times 3 and 3 times 5 are the same.
And you can always
Good.
just rotate it.
That's exactly right. Okay, did we learn any other shapes? Any other shapes? Yeah. The kite. Ooh. Did we learn the kite? Did we learn the kite?
Oh yeah, we did.
We did. The kite is similar to some of the ones that are here. How do we say the formula for it? Yeah, Will.
We do one of the half like I don't know.
Yeah, this is tricky. This is tricky. Danielle, do you want to have a go?
Half of the D1, D2.
Okay, yep. So D1, D2. What are D1 and D2, Ethan?
So you put a line down the middle, and D1
Yep.
is the left side, and D2 is the right side.
Okay, almost. We do have that line down the middle. Why is that line important? It's the what kind of line is that? Starts with a D. That's why it's D1.
Divider.
It's a diagonal, right? It divides it in half. Okay. You got one diagonal, you got the other. Multiply together, you halve it. Okay. Was that it? That looks pretty good to me. Are we missing any? Yep. Aha, very good. And I think this should be our last one. What was our area of a parallelogram? Yes. Okay, B, H. Now be careful. What are B and H? Yeah, Jordan. Okay, yep. Breadth and height. And be really careful, right? I might even put this on another color. And maybe you want to go back to yours, right? Height has to be perpendicular. Right? It has to be perpendicular. It's not this guy over here. That's not height. One of the ways I remember it is the perpendicular height. It literally looks like an H. Can you see that? Like there's an H there, right? So that's how I first remembered. Oh, okay, the height, it has to make that right angle. Otherwise, it's not the height. It's like leaning over. Okay. Yep.
The other teacher that we had said you cut one of the things off.
Yeah, that's right. So, and that's a great transition into what we're about to do. If what I do is I cut off slice off a triangle and then just like move it around, what you end up getting looks a whole lot like a rectangle, right? So that idea leads us right into this heading, which is composite shapes. Please make that heading if you haven't already. This idea of taking a shape and considering it as like little parts put together. That's what composite shapes are. Composite shapes are figures that are made up of other shapes. Just like this parallelogram, you can say, oh, it's like a triangle here and other bits, and they're all added together. Okay, that's what composite means. In fact, if you have any siblings or friends, family friends, or anything like that, who are engineers who work with materials, they'll often talk about composite materials, right? Which is like when you put together more than one like metal, for instance, and it comes together and makes something else. Okay, same deal with composite shapes. You put together multiple shapes, you get something else. So composite shapes are figures made up of other shapes. Okay? So, all of these formulas that you gave me just now, they're all about area. We moved past perimeter a little while ago. So, to measure their area, because composite shapes are a little trickier than just regular shapes, right? We've got a few steps here, and I've got kind of, I couldn't make a proper word out of this, but DDCC hopefully is memorable enough. There are 4 steps to working out the area of a composite shape, and they go along like this. Step number 1, draw. Right? We always begin with a diagram in geometry so you can see what you're looking at and work with it. Step 1 is draw. Second step is divide, as in like cut it up, slice it up into different pieces, and I'll show you an example of all these. When you divide, that's also, as you'll see in a minute, a really helpful time to label what you've got there. And then our last 2 steps are not D's, they're C's. So then, after you've divided, you calculate. You'll have a whole bunch of different pieces and you calculate each one. And then the last part you do is you've got all these pieces now, but there's really one shape, right? So you combine them back together. And there's a couple of ways to do that. So, steps 1 through 4, draw, divide, calculate, combine.